Hi everyone. I hope you can hear me. I had some troubles with sound and now it shows me that it can hear me, so I hope you also can hear me. Let me know if it's not true. And today we continue talking about performance measurement in Rapise tests. And we proceed talking and we dive deeper into this topic. And today I'll show you how to utilize some local global libraries for that to add some more convenience to performance measurement, and also how to use extra RL columns for this purpose, which makes it sometimes even more uh, convenient. So let's begin. So here we have screen with Rapise. I'm creating new test. It would be new test. It would be just local test for now. Perf, for example, perf measurement demo. It may be web or desktop. Let it be desktop. And let it be RL. So we have new completely clean test. And I'm not going to record anything. I'm just going to write few sections in this RL that are doing something really simple, and then try to measure how fast these sections are executed. So first would be doing tester message. Let me say part 1. And then it would do global do sleep. Oops, not do send case, do sleep. 1 second is good, but let me make it a bit less. 300 milliseconds. And finally, tester message part 1 done. Like that. So this is something really trivial. If I execute, I should have just 2 lines in the report, and the difference between these 2 lines, something close to 300 milliseconds, a bit more in this case, because some additional time went to like writing to report to additional things. But in general, if I execute it many times, I would get average 300 milliseconds as delay between these actions. And so this is a section that takes some time to execute and output something to the report. I want to measure how long it takes. Previously, we were talking about using test begin, test end for that. But for more convenience, I just added some utility library to Inflectra GitHub into the PowerPack project. And we may use it now and try to see what benefits it gives to us. So I'm Googling for Inflectra GitHub. It has Rapise PowerPack. It's the first here. And here there is a perf checker with lib. So this is a sample project having some performance checker, and this performance checker is implemented as a library. And right now I'm just going to take that library, put it into my project that I just created, or in my test, and use it to measure something. So I'm downloading it. It's here in the download section. Let me open it. So this is perf checker with lib. And if it's a lib, there is a lib subfolder. So I will need this lib subfolder. And I will need to put it into my tests, into my test as a subfolder. So in my test in Rapise, I'm clicking on any file in the files view, like on main.js, for example, and choosing Reveal and Explore. I just needed to open Windows Files Explorer in this folder. So now I'm just dragging this lib from my zip package that I've just downloaded into this folder. Copy. So the lib is here, and if it's just right now it's just a single test. If you have a test framework, you will need to do this to put it into your framework root, into the root test of your framework, and this lib will be available for all tests inside your framework. In my case, there is no subtest, so it's just in the root of my test, and that's it. Okay, and now, so now I may already use it, but it's not really convenient until it's really added. So let me, first let me refresh. You see, this library adds this perf object. It just shown up in the object tree, and it has a number of interesting methods. So it has two methods, begin section and end section. So these are ones I'm going to use. So begin section, I need to specify a name. So which my own name that I understand for the section of the code. So let me call it part one. And somewhere in the end, let me add a new line. So it's an easy way to add a new line. You stay here or here. So I'm using keyboard and cursor case. I don't like use mouse too much, but I could do this with mouse, but I like keyboard. So I may stay here and press Shift and Enter. And this adds a new line. So it's an easy way for adding new lines into RVL script. And I want to add end section here. So it will start the section part one, it would end the section part one. Let me play it and see how it works. Okay. And you see we have this output part one done. And then this is actually a line introduced by end section, and it has expandable section. And it says that the section part one took 344 milliseconds in total, and it was executed once, and its total time 344. Its minimal execution time is 344. Its maximal time is 344, and its average time is 344. Right now, there's just one number everywhere, but it's just because only one occurrence has been done so far. This library allows you to measure the section while it is executed somewhere, for example, in a loop, and then work with like total execution time. So you may, for example, assert that on each occurrence, each execution of some operation is not slower than something. So it's always faster than a second, for example. Or you may do it many times and just assure that its average execution time is not less than a second. So sometimes that there may be more delay due to loading from cache, due to network latency, but in general, for many iterations, it should give you some reasonable number. Also, you may just make sure that maximum time is not more than something. So it should never exceed some threshold. So there are different numbers available, and they are available here through get average, get max, get min. And also there is a built-in assertion. So I may use this assertion here. I may say assert last. So assert that last execution time is not is less than 1 second. So it's less than 1000 milliseconds. And section ID should be the same as I specified here. So part one took not more than a second to execute. Let me play that. And here it is. So there is my assertion. It confirms that my measurements are showing what I expect. So expected number is 1000. The threshold is 1000. Actual time was 328 this time, so it's a bit faster than last time. and it fits into the 1000 milliseconds threshold. Now, actually, I don't really like that these lines are gray or black. I would prefer them to be green, just to for this report to look closer to what I usually see in the report. So instead of tester message, I would use tester assert. So RL has its own assert statement, but it's also possible to use tester assert to just have a fixed assertion when the result is like the result of the assertion is always true, for example, or always fail. So tester assert, I'm changing message with assert, pressing tab. So it keeps this message parameter equal to part1 and adds additional parameter which is essential for assertion. It's a condition, and condition would be true because it's past assertion. I'm not going to fail at this point. Again, doing the same here, assertion is true. So these two lines should be green now. Let's play. You see, yeah, this section is green now, and finally there is a check that threshold is fine. So this is a simple usage of this library, and it's to some extent it's similar to usage of test begin test end, but we have special assertions and we have iterations, so it's already useful for actually managing and measuring the performance of some actions. Now let me show you more advanced usage. It's more advanced in implementation and not in how it looks. So to apply it, I need to say performance set RVL column. And here I may specify column index. And usually index is one of H, I, or J. So the column H in this case would be used to mark the sections to capture the performance. Now let me copy this section and just modify it to say, oh, part 2 done. No, it was part 1 done. You see, sometimes I need to edit something inside the cell in RWL, and it's a bit tricky. So if you just go to this cell and try to use cursor keys to select something, it may leave the cell. So there are two ways. One is to use mouse, select and change it. But if you, like me, use keyboard, then it's more convenient. So when you enter some cell, like here, and you cannot use cursor, you may use F2. In this case, the editor locks to this cell, and cursor keys in the keyboard just help you to move in this text. So I'm changing 2 with 1, and that's it. Part 1 done. So this would be part 2. Let me also change this threshold somehow, like let it be 200. And now in the H column, I may specify which section I want to collect the information of the execution into. So I may say, let the section would be P2. So, and I need to specify it for each action that belongs to this section, P2, P2. In the end of my script, I'm going to add just some operation, all done, just saying something here to finish my script. So these cells mark that these actions do belong to section 2. And now next operation here contains nothing in H column. And that would mean for the performance checker that if there is an action with no H after last action that has H, that means that H section is done, and it calculates the whole length of this section in this case. Or if I mark this section like this, and if after executing this action, it proceeds to this action. It would assume that this section is done and start this section. So this automatically switches from one section to another. Both way, okay. So I may just either have it empty. This would mean new section, or not new section, but the end of previous section. Or I may specify some new section name that would mean end of previous section and start of new section. So some information is collected here, and let me play it. So you may see part 1 as before, and part 2 is here, and in the end of part 2 we have a message saying some measurements for this part 2. So it's automatically collected just before saying all done, because it sees that the section is done and we need to output information about performance here. Next, I want what happens if I execute a section for several times. And let me copy this part 2 section just to save time, paste it here, rename it to part 3, pressing F2 to start editing, part 3, done. And it would be P3 section. So you see here I used part 1, longer section name. Here I'm using shorter one just because when it's repeated many times here, it's easier to use P3 than type in part 3. Or even if you're doing copy paste, in this case it requires less time to fit on the screen. So for example, I prefer shorter names, but some people like but more descriptive ones. So you may also use like part 3 with space or whatever, just to better reflect the section name. I'm fine with P3. So this P3 is going to be executed several times. And to do so, I'm selecting it here in RL, and I'm choosing a wrap selection into loop. And loop type would be variable, so fixed number of iterations like a for loop. And variable name is, let me call it loop int. So for loops, the variable name may be skip. So you may specify just nothing here. Oops, I cannot just. So you may specify just nothing here. Or if you want to use this current number of iteration inside the loop for something, that this is what we are going to do, then you need to define it here in the object column. It's not so evident, but you just need to know about this. So let me call it loop int. It's just, and inside this loop, it works as a usual variable that I may use. And I want to append this number of iteration here to the message. And I'm using this method where I specify the same parameter name for the second time. Loop int. So it would show part 3 and then loop int, so as a single message. And this would, so RVL processor would combine these two values and pass them as a message parameter to the tester assert. So this is how it works. And here I may do the same, or I probably don't need to do the same. So there is a cycle. So P3 will be executed 10 times. The delay, let me make it smaller, like 50 milliseconds. And let's play and see what we have. It's pretty quick. So in the end of each cycle, for example, we have the loop starts here, part 3. End of first iteration, it outputs the time for executing this iteration. It's so far there was just one occurrence of P3, and it took 110 milliseconds to execute. Then next iteration, So total execution time was 200. Last iteration executed in 94 milliseconds. And now we already may see that the execution time varies from 94 up to 110, and in average it is 102. And the same with iterations 3, 4, 5. For example, here in the iteration 5, we see the total time increases while average time is now closer to 97, while max and minimum is still the same. And finally, it should be iteration number 10. So, and it says that total execution time for this whole section while being executed 10 times inside the loop is less than a second, 958. So now, depending on my goals, I may do several different assertions. I may, for example, do perf and assert, for example, say that average time of P3 should be less than 150 milliseconds, which is a reasonable number of milliseconds here. Or I may do performance assert. What else I may assert? Last execution time, again, it should not exceed 150. And for 10 iterations here, I should have total time assert, and total time was a bit less than a second. So let me, P3, here should be 150, and here is P3 is a section name, and number of milliseconds is, let it be 1100. I think it should fit into this threshold. So let's play it now. Now the question is, why it thinks that this section is executed 10 times and not that this whole loop is a single operation? I may actually merge these actions and let me a bit rearrange here to first check total, because here it would fail if I merge them. So I may say that the loop is also action belonging to this section, and that's it. So why is it needed? Because currently the section actually breaks when it executes loop. After execution this action, it assumes the loop is another action, and since there is no age, it breaks and outputs information about last execution of section P3. But if I mark it as a part of the section, I think it should count the whole loop as a single solid block. Let's see if I'm right. Yeah. So the whole loop, you see only one output about the performance here, saying that there is just one occurrence and its total time is 860. So my check for total in this case is still the same, but okay, it's average, of course, higher because it's done in one iteration, what it was doing in 10 iterations. So what iteration is more heavy. So I may break it back. So, but I hope you got an idea on how to deal with a loop when you are going to use the columns in a way like that. Let me play. So you may have ideas on how to improve this performance checker, or you may have questions or suggestions. You're welcome to leave them here under this video, or you may just write us to rapise@infactor.com. We'll be happy to work with this example more, and if you think there is something interesting we may check, we will try to do this. In the next sessions, we may probably switch to other topics, and it may be related to this performance or may not. It would depend on what interesting will happen during the next week. So leave your ideas, you leave your questions here in the chat or in the comment section under this video, and any suggestions are welcome. We will be happy to try what you want to see. And for today, that's all I wanted to say. I see no questions so far. That's fair because it's only the beginning of this set of streams, set of regular streams. But I hope with time we will have online questions, I'll be more than happy to answer them online while or demonstrate them online. So you're very welcome. Just try to find announcements for next streams like this one and try to catch us online. And in this case, you will be able to provide some feedback and get some more information from us depending on your needs. Thank you for attention and see you next time. That's it. Goodbye.